we're going to see about the rotary cup burner of an auxiliary boiler, and this video is presented by myself and I'm Sriram. So the picture which is shown over here is a simple representation of a rotary cup burner on an auxiliary boiler. Let's now understand the basic components of a rotary cup burner on an auxiliary boiler. Let's start with the main fuel oil system, which is usually heavy oil. Here is the fuel oil inlet, and there is a main bank which has a pressure gauge, a pressure switch for low pressure, a thermometer, and a temperature switch or an alarm. So this depends on the design of the boiler. It can vary. After that, it goes to the compound regulator, which regulates both the air and the fuel. Thus it controls the air-fuel ratio with the help of cam profile, which is over here. And after that, the main fuel oil goes down to the shut-off valves. There are two automatic shut-off valves and one manual shut-off valve, and there is a recirc line. After that, we have a flow meter here, and there is a flow meter bypass which is kept always shut. After the flow meter, it enters the burner through the hinge of the door. This has to be noted. Through the hinge of the door, the oil enters the main burner, and thus it reaches the combustion chamber or the furnace. And let's see the pilot fuel system or the pilot diesel oil line. From the igniter pump, which is usually located in the purifier room, the diesel oil comes through two manual shut-off valves, and then with a flexible hose it enters the pilot burner. And the pilot burner also has two electrodes which ignite an arc under high voltage, and there's a cable which is going to the junction box from here. And the burner, it rotates at a very high speed through a belt driven motor. So let's now understand how the oil is getting atomized. The fuel oil, which usually comes at 2 bar, 1 to 2 bar, depending upon the boiler design and the ship's boiler fuel oil system. So I'm just giving a rough example of 2 bar. After reaching this point, the 2 bar is being accelerated and then atomized by the centrifugal force of the rotary cup burner. The rotary cup burner spins at a very high RPM, thus giving a very high acceleration to the fuel particles, and a continuous blast of primary air atomizes the fuel and thus make it a fine mist in the combustion chamber or the furnace. So now let's see the cross-sectional view. Here is the electric motor which drives the burner rotary cup through the belt drive, and the primary air enters here. This is the primary air damper, which is to be noted, and through this it enters, forces the oil and mistifies it, and the mist gets distributed in the combustion chamber. Let's now see where the secondary air comes from. So from the forced draft fan, the secondary air comes here through the wind box. It reaches the combustion chamber or the furnace. So this is the wind box, and the main point what you have to note here is these dampers. The damper over here is controlled by the compound regulator, which I explained already. And let's now zoom it and understand how exactly the compound regulator works. Servo motor has the linkage which controls this cam. So here is the cam profile, and here are the rollers. So what happens is, as the servo motor gives a signal, the linkage moves up. As the link moves up, the cam starts to rotate in this direction, and as it rotates, you can see the pointer here. The fuel will increase 6, 7, 8 and maximum 10. And it works other way around. As the link goes down, alright, I'll just clear it off. Alright, now if the combustion automation system gives as the servo motor to reduce the fuel, the link comes down, and as the link comes down, the cam profile moves in this direction assisted by the rollers, and this moves 5, 4, 3 and finally 1 and then 0 over here. So this is the cam and cam profile. And what happens to the air? Since the cam is moving up and down depending on the boiler automation system, the cam is attached to this through the linkage here, and then this link is controlling the dampers. Let's say as the link moves up, the cam moves this way and the link opens up more air, which means the linkages move in this direction, thus becoming in this fashion and allowing more air to match the amount of fuel. But what is behind this compound regulator? There is a simple valve, a flow control valve, which exactly opens depending on this position. The amount of fuel oil flow is controlled by amount of the valve opening. That's very simple. So let's now again go back to the details of the flame pattern especially. So this is a close-up view. Now let me open up the sketch. Alright, so here's the igniter or the pilot burner. Here is where the diesel oil comes from. So this is where the pilot diesel oil comes, and here are the electrodes. You can see a small electrode here. It will be somewhat like this, arranged like this, and you have to always measure the clearance between these two. It will be stated in the manual. In my last ship it was approximately 3 mm, roughly of this value. You got to refer the manual and adjust it accordingly. Only when it is properly adjusted, the diesel oil, when it comes out, catches flame and then interferes here with the main fuel mist. As the flame of the pilot burner extends in this area, as we know, there is a huge mist which is coming out of the main burner. It catches a flame, and thus once the flame cell or the flame sensor detects the flame, the pilot fuel is cut off. Once the pilot fuel is cut off, the main flame catches and then it keeps firing. So let's now understand what is the primary air and secondary air doing. The primary air comes through the burner and then with a high velocity forces the fuel particles and then creates some mist over here, thus forming the primary flame. And the secondary air, which is coming from the top through the forced draft fan, enters here, comes over here, and then extends the flame little bit more and then makes a complete combustion. Thus the secondary air or the extra air is required for complete combustion of the fuel particles. So what you see over here is the pilot burner, and this is the flame cell connection, and here is the peephole which you can slightly open up, and there is a side glass to check the flame combustion characteristics. And Nothing more to specify here. Wow, let's see what is this. This is a junction box for manual operation or emergency operation of the boiler. To operate the boiler in emergency, what you have to do is disconnect the servo motor, and there is a manual handle provided here to operate or adjust the fuel cam or the compound regulator. So this button is for increasing the compound regulator, and this button is for decreasing the position of compound regulator, and this will be for ignition of the pilot burner or the igniter. So the position depends on the design of the boiler. So that's it. Thank you for watching the video. For more videos, log on to dieselship.com.